Hello everyone, welcome to a new video. This video is about the psychrometric chart, and this psychrometric chart can be found at the back of your book. And actually it's the basis used for air conditioning, because it tells us something about whether we need to cool, whether we need to heat things up, whether we need to humidify or dehumidify, and what will happen to enthalpy and specific humidity, relative humidity. So that's actually quite useful to use. But the first thing we need to do is to look at two thermometers. I've got one here and one over there. And over both of the thermometers an airflow is flowing. And actually it has temperature T1, specific humidity omega1, and relative humidity psi1. And the same happens over here. We've got the So the conditions are actually the same, but there's a difference between both setups, because this thermometer is covered with a wet wick. So it's covered in a cloth that's submerged into water, so there's always some water surrounding this thermometer. And you can imagine if a flow is moving past this thermometer, that it will absorb some of the water that's in there in the form of a vapor. So there will be a temperature T2, there will be specific, this will be omega2, this is psi2, and over here we've got T2, omega2, psi2 as well. And in this case, well, of course, the temperatures here, T1 and T2, will be the same, because no energy has been used, no heat has been converted into water vapor. So liquid water has not turned into water vapor, but here it will be different. And well, of course we can assume that if the relative humidity is 100%, then we know for sure that over here the relative humidity will be 100% as well, because there's no need to absorb any water into the air. So this will remain constant. So, and therefore there's no energy has been used to vaporize the water that's covering this wet wick. So T2 will be equal to T1. But if the humidity of flow 1 is smaller than the humidity, the relative humidity of flow 2, which is 100%, the flow is saturated after passing the wet wick, then we know that some energy has been consumed, has been used to evaporate the air that is flowing around here. So this temperature will be lower. And in that case, T2 will be lower than T1. And this reading, so TA, will be different from this reading. So if this is happening, then TA will be different, will be lower than TB. And this is actually a definition, this is a measure we use. This is called the wet bulb temperature, and this is called the dry bulb temperature. Okay, now we have discussed the wet bulb and the dry bulb temperature. Now I'm going to dive into the psychrometric chart. And let's first draw a system of coordinates. So over here, we've got the horizontal axis, we've got a vertical axis, and on this vertical axis we've got the specific humidity, and on the horizontal axis we've got the temperature. And then there are certain lines, and these lines, actually there's one here, this is the most important one. This is the line of relative humidity, and over here it's 100%. And I guess somewhere over here it will be 0%. And let's just finish it over here. So here we have our psychrometric chart. And actually I'm just going to fill it with my data I have, because there are lines like these. And these are the relative humidity lines. Let's assume it's 70% over here, it's 50% over there, and it's 10% over here. Just to give an indication. Then in this chart I can read the temperature, I can read the the specific humidity and relative humidity. I can read the wet bulb temperature over here, the wet bulb, and so there are ISO lines, they're constant over here, so it's constant. So over here as well. These are lines of entropy. Enthalpy is constant. So here as well. Enthalpy is constant along these lines. And actually in your book, table A31, there the wet bulb temperature isn't even indicated, it's just enthalpy. And we can read the volume as well from this table. And that looks like lines like, just pick another color, lines like these. So specific volume is constant here as well. There's actually one thing that's really interesting to read from this. That is, if we have a certain temperature, we go to the saturation point, saturation line over here, then we know that the temperature over here will be equal to the wet bulb temperature, since it is 100% saturated over there. So we've got a saturation, 100% saturation over here, so it will be the same temperature over there. So, and all these kinds of information we can get really in a convenient manner from this chart, and it's in the back of your book. In the next video I'm going to explain how we can use this in our air conditioning process. So see you in the next video.